Okay, a box is shaped like a rectangular prism. It has side lengths of x and x plus 2, x plus 10. So we'll go x plus 2, and x plus 10. Write a function for volume. So volume equals the length times the width times the height. Okay, that's it. That's all it's asking for. You are going to make a rectangular box by cutting the corners off and flipping the sides up. So the new length of that is going to be 12 minus 2x, because you're going to cut that off. Same with this, 8 minus 2x. And then when you fold it up, the height of the box will be x. So we need to do option D. Christine dives off a diving board. Here's her equation. Height meters times seconds. Given that this is a factor, determine the other factors. So I'm going to synthetically divide. And 1, negative 3, negative 1, and 3. 1, multiply, add, multiply, add, multiply, add. So we have the function h of t equals, the first factor was t plus 1. Then this would have been t squared minus 4t plus 3. And this will break down to t. And then we're going to do a 3 and a 1, both negative. Okay, so that's determining the other factors. We have them listed. Sketching the graph over the interval 0 to 3. Okay, so this is going to have x-intercepts at negative 1, 3, and 1. And its y-intercept is 3. And it is a cubic. Okay, but I don't want all of that because it says over the domain 0 to 3. So we're only going to start there. So the height is 3 on that one, the x value is 1, the x value here is 3. Okay, so now that's all I want. Oops, sorry. Nope, I did that wrong again. I don't want the arrow there. I messed that up. I only want to a domain of 3. So I need to stop my graph. Okay, so not that part of the graph. So from x of 0 to 3, okay, so that's the idea, only graph that part of it. Okay, so from 0 to 3. And then question C is how many seconds is she under the water? So from here to here, she's under, and that answer would be for 2 seconds. Okay. Now, number 4, you're doing the planter shape volume of a box. Determine the factors which represent the possible dimensions. So we're going to try to factor this. So we're going to test 1. 1 cubed plus 3, 1 squared, minus 34 times 1 plus 48. 1 plus 3 minus 34 plus 48. So that is not 0. Let's test 2. 2 cubed, etc. Keep plugging in a 2. Is 8 plus 12 minus 68 plus 48. And that is 0. So I'm going to do a synthetic division with a 2. So 1, 3, negative 34, and 48 are the coefficients. Bring that down. 1, multiply, add, multiply, add, multiply, add. So this is an x squared plus 5x minus 24. And we already had a 2 that worked, so x minus 2 was the other factor. So x, and to get the 24, I'm going to need the 8 times 3. So x equals negative 8, x equals 3, or x equals 2. Okay, now I can't have negative 8 because that does not make sense. So determine the factors which represent possible dimensions of this planter. So if x was 3, or if x was 2, those would make sense. Okay. If the volume of the box is represented by that, identify a possible value of x. Okay, you know what, I'm going to graph this. Actually, let's just graph this one too here. So we have x equals negative 8, 2, and 3, and the volume would be like that. So volume can't be negative, and our x length can't be negative. So kind of that's the only understanding that would work. So x could be that zone. Okay, identify the possible values of x for number 5. So negative 4, negative 2, and 1 would be the x-intercepts of this graph. Okay, so that would be the graph of this. We understand that x, we can't have a negative dimension, so if this was negative 4, plugging it in would create a 0 dimension, so that wouldn't work. Plugging this in would create a negative dimension on that. Plugging this in would create a 0 on that, so that's not a dimension. Plugging 4 in would create an 8 times a 6 times a 3, so that would work. Okay, the height of fishing, a fish jumping out of the water is this equation. So sketch the graph. So an x-intercept is 0, 1, 4, and 5. And this is a 1, 2, 3, 4, and it's a negative shape. So that's what it would look like. But we want to only sketch it from the interval of 0 to 5. So with the domain, our graph should look like this. Okay, so I'm only going to graph that part of it because of the domain. State from the graph the total number of seconds the fish is above the water. So the fish is above the water here and here. So this is 1 second and this is 1 second, so that would be for 2 seconds that the fish is above the water.